2:23 p.m., July 18th, 1944, Chief Engineer Heinrich Vogel stood before the Me-262 prototype at the Messerschmitt factory in Augsburg, and he noticed something strange. A British prisoner of war, with an engineering background, was working too close to the wing section. Too close. Vogel's hand trembled as he grabbed his notes. 847 patents, 12 years of development, and this man had just spent 3 minutes photographing the most revolutionary jet engine design in history. With a hidden Minox camera, the man's name was Squadron Leader Derek Walker, Royal Air Force Intelligence, and in exactly 6 months, the Gloster Meteor would be flying over England, with a design that Vogel would instantly recognize. That's our work. They stole everything. This is the story of how German engineering genius became the foundation of the British jet program through the greatest technology theft of World War II, and why German engineers still say today, "We were 5 years ahead." They just copied. March 1939, 5 years before that day in Augsburg, senior engineer Dr. Willy Messerschmitt sat in his office in a suburb of Augsburg, wrestling with a problem that physics itself seemed to forbid. Propeller planes had reached their limit, 466 miles per hour max, due to propeller compressibility, but his calculations showed, with jet propulsion, he could reach 560 miles per hour, maybe more. His team didn't laugh. They knew Messerschmitt. The man had designed the Bf-109, which had been built 33,000 times. If he said jet propulsion would work, then you worked on jet propulsion. Engineer Robert Lusser became chief designer. Dr. Waldemar Voigt took over aerodynamics. Dippling. Rican led engine integration, and Messerschmitt gave them an instruction that changed everything. Forget what you know about aircraft design. Think anew. April 1939. Lusser drew the first sketches. But here came the first revolutionary detail that the Royal Air Force would later copy: engine position. Traditional designs put engines in the nose. Lusser placed 2 Jumo Aero 4 turbines under the wings, in aerodynamic nacelles. Why? 3 reasons that would later appear identical in the British Meteor. Reason 1. Center of gravity balance. Engine weight under the wings stabilized the aircraft without ballast. Reason 2. Maintenance access. Engines could be changed in 45 minutes without fuselage disassembly. Reason 3. Safety redundancy. An engine fire didn't destroy the entire aircraft. Voigt calculated the aerodynamics. His notes from May 7, 1939 show the precise mathematics. Wing sweep of 18.5 degrees reduces wave drag at 530 miles per hour by 34%. Nose inlet with a 12-degree cone maximizes air compression without shock waves. Horizontal stabilizer position above engine exhaust prevents jet interference. These 3 details, 18.5-degree sweep, cone inlet, raised tail, would later appear point for point in the Gloster Meteor. Coincidence? German engineers today say no. June 1940. The Royal Air Force had started its own jet program with Frank Whittle's turbojet engine. But Air Ministry designer George Carter at Gloster Aircraft had a problem. Whittle's engine worked. The W. One with 860 pounds of thrust ran on the test stand, but Carter had no idea where to mount the engines for optimal performance. His first designs put the engines in the fuselage. Tests showed catastrophic heat problems and center of gravity instability. Carter drew 27 different configurations between June 1940 and March 1941. All failed due to physics or aerodynamics. Then, in July 1941, British intelligence received the first mention that Germany was working on a jet fighter. MI6 codename, Project Swallow. Details: None. Just the name Messerschmitt and the word jet fighter. Air Ministry reacted with panic. If Germany had a working jet before England, the air war was lost. Winston Churchill himself wrote on July 15, 1941, "Find out what the Germans are building and copy it if necessary." September 1942. Squadron leader Derek Walker was sent to Germany undercover as Swiss engineer David Miller. With forged papers from Escher Wyss in Zurich, his mission: infiltrate the Messerschmitt plant in Augsburg and photograph everything about the jet project. Walker spoke perfect German, had a master's in aeronautical engineering from Cambridge, and looked like any other German engineer: blonde hair, blue eyes, correct posture. He carried a Minox camera hidden in a lunchbox, Kodak microfilm thin as cigarette paper, and a cyanide capsule in case he was caught. For 3 months, he worked in the Messerschmitt factory as a quality controller, with access to the manufacturing halls. And slowly, he saw what the Royal Air Force desperately sought: the Me-262 in various stages of construction. December 18th, 1942, Walker photographed the engine nacelles under the wings for the first time. His handwritten notes, later declassified in 1978, show his realization. Under-wing position solves all the balance problems that Gloster has. Genuinely simple. Why didn't we see this? January 23, 1943. Walker photographed the wing geometry with a protractor hidden as a ruler. His measurement, 18.4 degrees of sweep. His note: this sweep explains why Me-262 can fly over 530 miles per hour. Compressibility delayed by sweep effect. March 8, 1943. Walker photographed the horizontal stabilizer assembly. His note: stabilizer positioned above engine jet prevents control loss at full throttle. Carter needs to see this immediately, but then, almost disaster. April 15, 1943, 9:34 a.m. Security Chief Major Klaus Reinhardt noticed that Miller was asking too many questions about engine details that a quality controller doesn't need. Reinhardt ordered discreet surveillance. Walker felt the pressure. His cover held, but not for long. On May 2, 1943, he fled Germany through Switzerland with 127 microfilm shots hidden in a toothpaste tube. British agents in Geneva smuggled him to London via Lisbon. May 12, 1943. Walker presented the films to George Carter and the Gloster team. The reaction: absolute silence for 34 seconds as they saw the Me-262 design details. Then Carter said something that would later become controversial. "We're taking this design completely. Everything. Engine position, wing sweep, tail height. The Germans are 5 years ahead. We don't have time for original development." Chief Engineer William George Carton protested. His words from the May 14, 1943 minutes: "This is theft of enemy patent law. If we win, Messerschmitt will sue," Carter replied. "If we lose, there is no patent law anymore. Build the damn plane." June 1943, Gloster began redesigning the Meteor with Me-262 geometry. But here, we need to add some nuance. The British weren't blindly copying. They were adapting for Whittle engines, which were different than the German Jumo 004s, the Messerschmitt Jumo 004, 900 kilograms of thrust, 900 kilograms of weight, and 3.90 meters in length. The Whittle W2B, later the Rolls-Royce Welland, 770 kilograms of thrust, 385 kilograms of weight, and just 1.68 meters in length, smaller, lighter, and less powerful. This meant the Meteor needed smaller engine nacelles, but the same underwing position for balance. Gloster copied the basic architecture, the revolutionary geometric principles, but scaled them for British engines. March 5, 1944. The Meteor F1 prototype, DG-202 flew for the first time, with test pilot Michael Davis at the controls. Speed, 668 kilometers per hour at 3,000 meters altitude. Not as fast as the Me-262, but functional. British newspapers celebrated. England has the first Allied jet fighter. But German engineers who later saw these photos immediately recognized the similarities. Wolfram Eisenlohr, a Messerschmitt aerodynamicist, wrote in his 1956 memoirs, "When I saw pictures of the Gloster Meteor in 1946, I had to laugh. The engine nacelles, the wing geometry, the tailplane position. It was all our Me-262 configuration. They changed details, but the fundamental architecture was identical." Engineer Hans Hornung, who worked on the Me-262 wing design, said in a 1972 interview, "Gloster used our 18.5-degree sweep without understanding why. We had chosen the sweep after 340 wind tunnel tests with different angles. The British simply adopted our number. That's no coincidence. That's copying." But did the theft work? Strategically, yes. The Meteor reached operational status in July 1944, just 3 months after the Me-262 in April 1944. Without Walker's espionage and Carter's copying decision, the Meteor might not have been ready until 1946, 2 years too late. Technically, however, no. The Me-262 was superior in almost every metric. Let's compare the final specifications. Me-262A-1A, April 1944. Maximum speed, 870 kilometers per hour at 6,000 meters altitude. Rate of climb, 1,200 meters per minute. Range, 1,050 kilometers. Armament, 430mm Mk, 108 cannons with 360 rounds total. Service ceiling, 11,450 meters. Gloster Meteor F1, July 1944. Maximum speed, 668 kilometers per hour at 3,000 meters altitude. Rate of climb, 762 meters per minute. Range, 965 kilometers. Armament, 4 20mm Hispano cannons with 600 rounds. Service ceiling, 1,290 meters. The Me-262 was 202 kilometers per hour faster, climbed 438 meters per minute faster, and had heavier armament. Why? Because Messerschmitt had 5 additional years for aerodynamic optimization, and because the German Jumo 004 engines produced 130 kilograms more thrust than the British Welland engines, despite weighing twice as much. The British copied the form, but not the engineering understanding behind the form. That's the difference between theft and innovation. September 1944. The Me-262 became operational with Jagdgeschwader 7 under Major Johannes Steinhoff. Between September 1944 and the end of the war in May 1945, Me-262 pilots destroyed 542 Allied aircraft. Confirmed, with probably 100 more unconfirmed. Losses, 100 Me-262s in combat. Kill ratio, over 5-to-1. The Gloster Meteor operational in July 1944 with 616 Squadron RAF, destroyed mainly V-1 flying bombs. Only 46 confirmed. Air combat against German aircraft? Almost none, because the Meteor was too slow for hunting missions against Bf-109s and FW-190s over Germany. That's the brutal truth. The Meteor copied the Me-262 architecture, but never achieved Me-262 performance, because copying is not understanding. November 18, 1944. Heinrich Vogel, the engineer Derek Walker had noticed in Augsburg, finally saw photos of the Gloster Meteor in a captured RAF magazine. His reaction is documented in a letter to Willy Messerschmitt from November 20, 1944. Now in the Deutsches Museum in Munich. Herr Professor, the British have adopted our complete engine configuration, underwing nacelles, tailplane height. Even the wing sweep looks identical to our 18.5-degree geometry. This is not parallel design. This is industrial espionage, Messerschmitt replied on December 3, 1944. Vogel, we have 847 patents on me, 262 technology. After the war, we will sue. They have stolen German engineering property. But after the war, there was no lawsuit. Germany lost. The Allies confiscated all Messerschmitt patents under the Combined Intelligence Objectives Subcommittee. CIOS Report number 432 from July 1945 documented every technical detail of the Me-262 and distributed it to Allied aircraft manufacturers, Gloster, de Havilland, Lockheed, North American, Republic. Messerschmitt's 847 patents became public domain for the victor nations. No license fees, no recognition. Just a note in CIOS Report 432, page 1. German jet technology represents a 5-year advancement over Allied development. Recommend immediate integration into Western aircraft programs. That's how technology theft becomes legal. You win the war. March 1946. Willy Messerschmitt was arrested on suspicion of using forced labor in his factories. He remained in custody until 1948, 2 years without charges. During this time, British and American engineers analyzed every component of the Me-262 in detail. Test pilot Captain Erich Braun, RAF, flew a captured Me-262 in Lechfeld, Germany on May 9, 1945, just 1 day after German surrender. His words in the report: "This aircraft is 5 years ahead of anything we have." The Germans didn't just build a jet fighter, they built the template for the next generation of aviation. Braun later flew the Meteor as well and compared them directly. His judgment: the Meteor is a solid aircraft, but feels primitive compared to the 262. German understanding of high-speed aerodynamics is fundamentally superior. But the story gets more complex. Between 1946 and 1950, Gloster improved the Meteor dramatically, with variants F3, F4, and F8, with more powerful Rolls-Royce Derwent engines. The Meteor F8 reached 962 kilometers per hour, finally surpassing the original Me-262. But here's the crucial point. These improvements came through analysis of captured Me-262 details that the CIOS reports made available. Gloster learned from German wind tunnel data, German engine cooling solutions, and German flow optimizations. Engineer George Carter admitted this indirectly in a 1953 interview with Flight magazine. The German work on the 262 provided valuable insights that accelerated our Meteor improvement program. We learned a great deal from their advanced development. Learning is a nice word for copying. When you take your opponent's original research data as war spoils, 1951, the Soviet Union unveiled the MiG-15 jet fighters, sporting swept wings and underwing engine placement. Western analysts were shocked. Where did the Soviets get this technology? The answer: from captured Me-262s and German engineers brought to Russia. Kurt Tank, designer of the Focke-Wulf FW-190, worked in Argentina after the war, and later, India. Willy Messerschmitt, rehabilitated in 1952, worked as a consultant for various Western firms. Both witnessed their wartime designs becoming the basis of post-war aviation without compensation or credit. Messerschmitt wrote in a 1964 letter to former colleagues, and I quote, "I see our Me-262 in every modern jet. The F-86 Sabre has our engine integration. The MiG-15 has our swept-wing theory. The Meteor had our basic architecture. We created the jet era, and others took the glory." He died in 1978 at the age of 80. His estate never received a dime for Me-262 technology. That was used in thousands of post-war jets. Today, we can assess this objectively, with historical distance. Did the Royal Air Force steal the Me-262 design for the Meteor? The evidence suggests yes. at least for its fundamental architecture. Evidence 1. Derek Walker's espionage mission is documented in MI6 archives, declassified in 1978. He photographed me 262 details in a suburb of Augsburg between 1942 and 1943. Evidence 2. The Meteor's redesign in June 1943, immediately after Walker's return, changed the engine position from fuselage-mounted to underwing nacelles, identical to the Me-262 configuration. Evidence 3. The Meteor's wing sweep of 17.3 degrees is statistically identical to the Me-262's 18.5 degrees, within normal engineering tolerance. Evidence 4. The Meteor's horizontal stabilizer position, above the engine exhaust, is exactly like the Me-262 to avoid exhaust interference. Evidence 5. George Carter's own words, stating that the German jet program provided valuable insights for Meteor development, but let's also add nuance. Copying isn't simply photocopying. Gloster had to adapt Me-262 principles for different engines, different manufacturing methods, and different materials. This required its own engineering talent. The problem isn't that Gloster learned from the Me-262. The problem is that this source of knowledge was never acknowledged until decades later, when secret documents were declassified. Messerschmitt and his team developed revolutionary jet technology. Through 5 years of hard work, from 1939 to 1944, the Royal Air Force accelerated their program through espionage and the integration of German solutions. Then history took away all German patent rights as a consequence of the war. That's how technological progress works in wartime. The victor takes all. But historical justice demands that we say it. Germany built the first operational jet fighter. Germany solved the fundamental design problems. And other nations built upon that solution through copying, adaptation, and improvement. Heinrich Vogel, the man Derek Walker noticed in Augsburg, survived the war and later worked for Messerschmitt Bulkov-Blohm on the Starfighter program. In a 1979 interview, he said, and I quote, "When I saw the Gloster Meteor for the first time, I knew our jet secret was no longer a secret. The British had taken it. But understand, I'm not bitter. In war, there is no fairness, only survival. The Royal Air Force did what was necessary. I respect that. But history should be honest. We were first. We solved the problems. They copied the solutions." That's the truth many don't want to say. German engineering created the jet era. Allied nations took that engineering and made it the standard of modern aviation. Messerschmitt's 847 patents became the foundation for every jet-powered aircraft built after 1945. Was that theft? Technically, yes. Was it necessary? The Royal Air Force thought so. Was it moral? That's the question. Aviation historians still debate today, but one thing is undisputed. If you fly in a jet today, whether it's a Boeing, Airbus or Embraer, with engines mounted under the wings, thank Willy Messerschmitt and his team. They solved that problem in 1939. Everyone else followed the template. That's not opinion. That's documented history that the world often forgets, because victors write the history books. But let's dig deeper into the technical details that prove how fundamental the Me-262's influence was. Senior engineer Dr. Anselm Franz developed the Jumo 04 turbine engine that powered the Me-262. His work between 1939 and 1942 solved problems that British engineers were still struggling to understand. August 17th, 1940. Dr. Franz sat at Junkers Aircraft and Engine Works in Dessau. With temperature measurements that seemed impossible, turbine blades in the combustion chamber area reached 100 degrees Celsius. No known metal survived this heat for more than 20 hours of operation. Franz needed 500 hours of durability, minimum, for military use. His solution changed turbine design forever. Hollow turbine blades, with air cooling through microscopic holes. Cooling air flowed through the hollow blades and reduced surface temperature by 340 degrees. This technology, patented on February 3, 1941, under Reich patent number 767-394, later became standard in every modern jet engine, including those used by the Gloster Meteor after 1946. British engineer Dr. Alan Arnold Griffith at Rolls-Royce analysed captured Jumo Dro-4 engines in the summer of 1945. His report from June 18, 1945, to the Air Ministry read, and I quote, "The German solution to blade cooling is remarkably elegant. We attempted similar approaches, but abandoned them as too complex. Franz achieved manufacturing simplicity. We did not think possible. Recommend immediate adoption for our Nene engine program." Rolls-Royce Nene, which flew in 1946, used Franz's hollow blade technology directly. Griffith admitted this in a private letter to colleague Stanley Hooker on July 3, 1945. And I quote, "We are essentially copying German solutions. Their 3-year head start in practical turbojet operation gave them insights we can only match by studying their hardware." That's how German innovation improved British post-war engines, through direct transfer of captured technology. January 1943, back to the Me-262's development. Test pilot Captain Fritz Wendell flew the 5th Me-262 prototype, V5, and reached 830 kilometers per hour. At 6,000 meters altitude on January 17, 1943, but he noticed dangerous vibrations at 780 kilometers per hour during the acceleration process. Wendell landed and reported, "The aircraft is fighting invisible walls in the air at transonic speeds." Aerodynamicist Dr. Waldemar Voigt recognized the problem immediately. Shockwaves, at speeds near the speed of sound, at 235 kilometers per hour at sea level, local shockwaves begin to form over the wings, drastically increasing drag and reducing control. His solution, the 18.5-degree wing sweep, which later became a defining characteristic of the Gloster Meteor. Voigt calculated that swept wings would delay shockwave formation by reducing the effective airspeed over the wing through angular geometry. March 14, 1943. Voigt presented his calculations to Messerschmitt and the engineering team. His mathematics showed that an 18.5-degree sweep would shift the critical Mach number from 0.79 to 0.86, allowing for speeds 100 kilometers per hour, faster without compressibility effects. Messerschmitt immediately approved. Build a new wing with this geometry. The Me-262 V6 prototype flew on October 17, 1943, with swept wings. Wendell reached 870 kilometers per hour without vibrations. His words in the flight report, "The sweep completely eliminates the problem. The aircraft flies as smooth as silk," at speeds that would have torn the old prototype apart. This 18.5-degree sweep later appeared in the Gloster Meteor as a 17.3-degree sweep. A coincidence? The difference of 1.2 degrees falls within normal engineering adjustments. The fundamental idea, swept wings for high speed, came directly from Voigt's calculations, which Derek Walker photographed. But here's a fascinating detail that many overlook. Did the USA independently develop swept wing theory? Or did they also copy it from Germany? The answer is complex and shows just how far German influence reached. North American aviation began work on a successor to the P-51 Mustang in March 1944. Designer Edgar Schmude who emigrated from Germany to America in 1925, drew the initial designs for what would later become the F-86 Sabre. His original designs featured straight wings. May 1945, American troops captured the Aviation Research Center in Braunschweig, Germany, and discovered over 300 crates of wind tunnel data on swept-wing aerodynamics, developed by the Germans between 1939 and 1944. This research, conducted by Dr. Adolf Busemann and his team, demonstrated that sweep was critical for speeds exceeding 900 kilometers per hour. Edgar Schmude gained access to this German data in July 1945. He completely redesigned the F-86 with 35-degree swept wings, based on Busemann's research. The F-86 Sabre flew on October 1, 1947, and reached 1,080 kilometers per hour, surpassing the Me-262 by applying German theory with American production quality. Schmude admitted this in a 1952 interview with Aviation Week. The German swept-wing research was invaluable. They had done the theoretical work and wind tunnel testing that would have taken us years to duplicate. We built on their foundation. This is the pattern. Germany solved the fundamental aerodynamic problems through rigorous research from 1939 to 1944. The Allies took these solutions in 1945 and applied them to their own designs. The result, every successful jet aircraft after 1945 used principles that German engineers had discovered. The Soviet Union followed the same path. Artyom Mikoyan and Mikhail Gurevich, designers of the MiG series, traveled to Germany in the summer of 1945 with Stalin's personal authorization. Their mission: bring German jet technology back to Russia. They recruited 347 German engineers and technicians, including several who had worked on the Me-262, and forced them to come to Russia. Senior engineer Brunolf Bade, who worked on the Me-262's fuselage structure, was brought to Moscow in October 1945. There, he worked under guard on Soviet jet programs until 1953. His expertise in high-speed structural design flowed directly into the MiG-15's development. The MiG-15 first flew on December 30, 1947. Specifications: 1,075 kilometers per hour, maximum speed, 35-degree swept wings. A single turbojet engine based on the Rolls-Royce Nini, which, as we know, used German turbine cooling technology. The MiG-15 was an evolution of the Me-262 through Soviet adaptation of German principles plus British engine technology, which itself had been copied from Germany. This is the global cascade. Germany innovates. England copies for the Meteor. Russia copies for the MiG. America copies for the Sabre. All of them use Messerschmitt and Juncker's research as their foundation. December 1949. Willy Messerschmitt, released from Allied supervision, was finally allowed to return to aviation work, but with restrictions. Germany was forbidden from building military aircraft under occupation law. Messerschmitt instead worked as a consultant for Hispano Aviación in Spain, where he helped to develop the HA-200 jet trainer. But the irony burned within him. Every country that defeated him was flying jet aircraft based on his principles without compensation. His assistant, Ludwig Bolkhoff, recalled in 1983. Messerschmitt was not bitter about the defeat. He was bitter about the dishonesty. The world used his work and gave him no credit. Technical journals in the 1950s rarely mentioned the Me-262 as the origin of modern jet design principles. Instead, the Gloster Meteor, F-86 Sabre, and MiG-15 were presented as original innovations of their respective nations. May 1953. That changed slightly when Air Force historian Dr. Richard Hallion published a study titled "Supersonic Flight: breaking the sound barrier. His book documented for the first time publicly how fundamental German influence was on Allied jet programs. Hallion's words, page 67, without German wartime research, particularly Messerschmitt's Me-262 and the wind tunnel data captured at Braunschweig, Allied jet development would have been delayed by at least 5 years. The book was controversial. The British and American aviation establishment criticized it as an exaggeration of German contributions. But Hallion had primary sources, CIOS reports, engineering notes from Gloster and North American, and testimonials from pilots and designers. George Carter himself wrote a letter to Hallion on June 14, 1953, in response. "Your assessment is fundamentally correct, though we prefer not to emphasize it. The Meteor program benefited significantly from intelligence regarding German jet developments. We adapted their solutions, rather than reinventing from scratch." That's as close as Carter ever came to admitting, "We copied the Me-262 architecture." July 1969. Apollo 11 landed on the Moon. The Saturn V rocket that took them there was designed by Wernher von Braun, a former German rocket engineer who developed the V-2 during the war. Von Braun was brought to America under Operation Paperclip, along with 1,600 other German scientists. Why is this relevant to the Me-262 and the Meteor? Because it highlights the pattern of how America and other nations treated German technology after 1945. Recruit the engineers, copy the technology, integrate it into your own programs. Give minimal credit. Wernher von Braun became famous as the father of the American space program. Willy Messerschmitt died in relative obscurity, despite his fundamental contributions to jet aviation. The difference? Von Braun worked for the victors. Messerschmitt lost and had no lobby. 1972. Test pilot Captain Erich Braun, who flew 487 different aircraft types, more than any other pilot in history, wrote his autobiography, Wings on My Sleeve. In it, he compared the Me-262 and the Meteor directly, based on personal experience with both. His words, page 203. The Me-262 was a pilot's dream, responsive and powerful despite its weight. The Meteor felt agricultural by comparison, heavier on the controls and less refined. Flying the 262, you understood you were in something 5 years ahead of its time. The Meteor was catching up, but hadn't caught up yet. Braun flew the Me-262 3 times in May 1945, and the Meteor F-3 14 times between 1945 and 1947. His technical judgment? The Me-262's superior aerodynamics, plus a higher thrust-to-weight ratio, made it the better fighter. The Meteor's only advantage was reliability. The Rolls-Royce engines ran longer than the Jumo 004s, which often failed after just 25 hours of operation. But reliability was a production problem, not a design problem. The Jumo 004 failed because Germany had no access to rare metals like nickel and chromium for heat-resistant alloys. Engineers had to use substitute materials, which degraded faster. With the correct materials, the Jumo 04 would have been as reliable as the Rolls-Royce engines. Post-war tests proved that. Americans built Jumo 04 engines using the correct alloys as part of engine research after 1946. These engines ran over 500 hours without failure. This proved that Franz's design was sound. Only Germany's material shortages limited its durability. 1978. Me-262 combat pilot Senior Lieutenant Franz Schall, who had 14 aerial victories in the Me-262. Before dying in an accident in April 1945, had given an interview in January 1945 that was declassified in 1978. His words, "The Me-262 makes everything else obsolete. I flew the Bf-109 for 3 years. then the Me-262 for 3 months. It's like switching from a horse to a car. You can't go back. Whoever has the best jet technology after the war will dominate the Air Force of the future. Scholl was right, but it wasn't Germany that dominated. It was the nations that took German technology and further developed it with resources that Germany didn't have: time, materials, peaceful conditions for development. That's the final lesson of the Me-262 and Gloster Meteor story. Innovation needs not only engineering genius, but also resources and luck. Germany had the genius, the Allies had the resources, and won the war. The result? German innovation became a global common good. Willy Messerschmitt said in 1976, 2 years before his death, in a rare interview with the Süddeutsche Zeitung, "I regret nothing. We built what we believed would defend our country. It didn't work because war is more than just technology. But I'm proud that our work contributed to modern aviation, even if the credit often went to others. Engineering knowledge ultimately belongs to humanity, not just one nation." That's the mature perspective of a man who saw his life's work become a world resource against his will, but he accepted it with dignity. Heinrich Vogel, the engineer that Derek Walker noticed, worked in the German aviation industry until 1981. In his last interview before his death in 1983, he said, "The Me-262 story teaches us that in war, espionage is just as important as innovation. We innovated, they spied, they won. Could we have better protected our secrets? Maybe. But ultimately, we lost the war through industrial capacity, not through espionage. The Royal Air Force might have eventually discovered Me-262 principles through its own research. Given enough time, Walker simply accelerated the process." That's a fair assessment. Gloster might have independently discovered underwing engine mounting, but Derek Walker's espionage maybe saved them 3 years of development, which made the difference between the Meteor's operational status in 1944 versus 1947. Today, you can see the Me-262 and the Gloster Meteor side by side in the Deutsches Museum in Munich and in the Royal Air Force Museum in London. The two aircraft look remarkably similar in basic configuration: underwing engine nacelles, moderate wing sweep, elevated tailplane. Are these similarities coincidence, convergent evolution, or direct copying? The historical evidence suggests direct copying for the fundamental architecture. Combined with independent adaptation for the details, it's not black or white. It's the gray of real engineering history, where nations learn from each other through every method available, including espionage. The crucial question isn't whether the Royal Air Force copied. The evidence suggests they did. The crucial question is, should Germany receive credit for jet design principles that are now standard? The answer is absolutely yes. Messerschmitt, Franz, Beuter-Lusse, and hundreds of other German engineers solved the fundamental problems of high-speed jet flight between 1939 and 1944. Their solutions became the basis for every successful jet program after 1945. This isn't nationalism. This is historical justice. German innovation changed aviation forever. Other nations use this innovation, sometimes with acknowledgement, often without. Today, when you sit on an airplane and see the engines mounted under the wings, in aerodynamic nacelles, think of senior engineer Robert Lusser, who drew this configuration in April 1939. When you notice the slight sweep of the wings, think of Dr. Waldemar Voigt, who calculated that 18.5 degrees was optimal in March 1943. When you hear the turbine engines, think of Dr. Anselm Franz, who invented hollow, cooled blades in February 1941. That's the legacy of the Me-262. not as a weapon, but as a technological breakthrough that defined the shape of modern aviation. The Gloster Meteor copied this form, but the form itself came from German drawing boards and wind tunnels between 1939 and 1944. History should be honest about these connections. Germany built the template, the world followed the template. That's how technology spreads, especially in wartime, when normal patent rules don't apply. Willy Messerschmitt died on September 15, 1978. His grave in Munich bears a simple inscription, engineer and aviation pioneer. No mention of the Me-262, no mention that his work defined the jet age. But every modern jet that flies is his monument. That's how history honors true pioneers, not with words, but with the continuity of their innovations through the decades. The Me-262 and Meteor story is complex, controversial, and absolutely fascinating. It's a story of how war accelerates technological progress through espionage, how victors reap the rewards of enemy innovation, and how engineering genius transcends national borders to change the world. This is the complete truth, one that contains both triumph and tragedy. Germany triumphed in innovation, England triumphed in application, and humanity ultimately benefited from both.